So I'm going to answer your activity of integration question. And the question is, the first part of the question is, what is meant by inhibition of an enzyme? So an enzyme can be inhibited by saying, well, first, actually, let's identify our components. So this yellow-green thing, that is our substrate. And the substrate perfectly fits into the enzyme. It's known as the lock and key model. It fits right there, binds nicely. And then whatever happens with the enzyme, it'll release products. And we're just going to say for the point of this video that the products are what that substrate is, just like the components of it. Maybe the enzyme breaks it down. Maybe something totally different happens. It depends. But just for the understanding of what enzymes do and substrates, we're going to say that it breaks into the components. Okay, so inhibition of an enzyme is when you can't get the substrate into the enzyme because it's not fitting for some reason. Now that could be because of a competitive inhibitor, which has the same kind of like shape. And that's this like diamond kind of part that fits in nicely. And this is not our substrate. It's a dark green. This yellow, green, whatever you want to say, that's not going to be able to access that enzyme. So then you're not going to be able to split it up into the parts. Okay, so the next thing is talking about explaining how an end product inhibition in an enzyme-controlled reaction is a negative feedback, and explain the role of the active sites of an enzyme in enzyme specificity. So first, I'm going to talk about active sites. Active sites are where these things bind. They're where the substrates or the inhibitors bind. So an active site is perfectly matched for whatever it needs to be, or for whatever the substrate is. So it might be this little triangle here that matches the diamond with that triangle, or maybe it's this like square indent that you see over here matches here. You don't really know exactly, but it's something. The active site is where it binds, and that's the important thing. It has to bind right there. So for an end product inhibition, it's negative feedback. So the substrate will first go down to its initial enzyme. Or you could even say it'll go to both this enzyme and this enzyme. Because remember, these are all happening constantly. So this enzyme produces this product, which becomes the substrate here, and then another product substrate here, and this last enzyme produces this square, which ends up as our inhibitor for this substrate, which means the substrate will just keep going through here and will not be able to bind to this enzyme right here. I hope that made sense. Let me know if you have any questions. Bye.